Hello dear friends. Let's cover a topic on trigonometry related to heights and distances. Topic is mainly used in measurement of heights of tall objects such as hills, mountains, towers, and to calculate distance from the object to the point of observation. For example, we have a tower here and there is a person standing here and he wants to measure the height of this particular tower. So how do we measure? So this is what is explained by this particular concept. On the other hand, there's a person standing on top of the building and he wants to measure the distance of this particular vehicle to the building. At the same time, we can also calculate the height of the building. So basically, this entire concept of trigonometry for heights and distances is used in measurement of objects which are taller and also to measure the distance between the object and the observer. There are few key terms that we have to understand in this particular concept. First thing is the point of observation. The point of observation is the point at which the person or the observer is trying to look at the object. So here is the observer. This is the object, which is the tower. So he is trying to look at the object. Now here in this case, he has to lift his eyes or head to look at the object because object is at a higher level. So this point from the observer's eye till the top of the tower is the line of sight. And this line, horizontal line, from the observer's eye till the foot or the base of the tower is the horizontal line. The angle between the line of sight and horizontal line is the angle of elevation. Now, why is it called angle of elevation? Because he has to elevate his eyes or his head to look at the object. So it is called as angle of elevation. So this we call as the height of the tower. And this is as the foot of the tower. Now, there is another case where the person is standing on top of the building, right? In this case, the horizontal line is nothing but the line from the observer's eye that goes straight. It's a straight line from the observer's eye. So this entire line is called horizontal line. Now, there is also line of sight from observer's eye till the base of the vehicle. So this is called as a line of sight. So the angle between the horizontal line and the line of sight is called as angle of depression. Why is it called as angle of depression? Because the observer is looking down. He is looking down to look at the vehicle. That's why it is called as angle of depression. Here, in this case, the object is below his level. Object is at a level which is lower than his eyes or his height. So that is why it is called as angle of depression. And this distance between the building and the vehicle can be measured using this concept. So what is the difference between angle of elevation and angle of depression? Angle of elevation is a case when the observer is trying to look at the object which is higher than his eyes, higher than his level of sight. Angle of depression is nothing but the observer is trying to look at the object which is lower than his line of sight. Before we solve the problems of heights and distances, there are key things to remember that we learned previously as part of trigonometry basics, right? First thing is we'll have to remember formulas for sine theta, cos theta, tan theta, cot theta, and so on. So just to refresh the basics, I will go through each of this. ABC is a right angle triangle. This is angle theta. Opposite side to this angle theta is AB. Adjacent side to angle theta is BC. Hypotenuse is the side which is opposite to the right angle. So what is sine theta? Sine theta is opposite side by hypotenuse is sine theta. Cos theta is adjacent side by hypotenuse. Tan theta is opposite side by adjacent side, which is AB by BC. Tan theta is majorly used in calculating heights and distances because normally we have to calculate the height of the object and distance of the object to the observer's point. So normally we'll have to calculate either the opposite side or the adjacent side. Then cot theta is nothing but 1 by tan theta and tan theta is 1 by cot theta. We also have to remember tan 90 minus theta is cot theta. Cot 90 minus theta is tan theta. Similarly, sin 90 minus theta is cos theta and cos 90 minus theta is sin theta. And there is another important concept which we have to remember. when we are calculating problems related to angle of depression, the alternate angle concept. So in the angle of depression, we know the horizontal line moves from the observer's eye and goes straight. And the angle from the horizontal line to the object is the angle of depression. Now in this case, if the angle of depression is 30 degree, the alternate angle to this one is ACD. So if we have this angle 30 degree, this angle is same as this angle. So if we have one side and the angle on one side is given, the angle on the other side, that is alternate side, on the opposite side is the same. Both are equal. So if this is 30 degree, this will be 30 degree. If this is 60, this will be 60 degree. So in entire problems related to angle of depression, we will have to use this concept of alternate angles. So in this case, angle BAC, that is this angle, is same as angle ACD, which is this angle. And we will have to remember important trigonometric values. Tan 30 is 1 by root 3. Tan 60 is root 3. Tan 45 is 1. So we will have to remember all the values for sine, cos, tan, secant, cosec. All of that we have to remember. But I have highlighted few of the major things which we will have to frequently use in the problems. Let us take an example where we have to calculate the height of the tower. Angle of elevation is given. This is the angle of elevation. And the distance from the tower to the point of observation is also given. So we will have to find the height of the tower. So the key thing here while solving all heights and distances problem is we will have to visualize the diagram. We will have to visualize the entire problem statement. We will have to draw that and then we can solve the problem. So in this case, we have a tower. So this is the tower, right? This is the base of the tower or the foot of the tower. And then we have angle of elevation from the top of the tower, right? And this angle of elevation is at a line which is joining the foot of the tower. So this is the foot of the tower and this is the line of sight. The angle of elevation is given as 30 degree and the distance between the foot of the tower and the point of observation is 500 meters. So we will have to calculate the height of this tower. Say let's call it as H. So let's name this triangle as A, B, C. It's a right angle triangle. So if you look at this triangle, this will be the adjacent side. This will be the opposite side. And this is the angle of elevation, which is 30 degree. Why I call this as opposite side? Because this is a side opposite to the angle which is 30 degree. And this is adjacent side because this is the base for this particular angle. This line is the base for this angle and this line is the opposite side for this angle. So now, whenever we have opposite side and adjacent side given, or whenever we have to calculate one of the sides, be it opposite side or adjacent side, then we will have to use tan theta formula. So what is tan theta? Tan theta is opposite side by adjacent side. So in this case, theta is 30 degrees. So tan 30 is opposite side. What is opposite side? Nothing but H, because that's the height that we have to measure. And adjacent side is BC, right? Adjacent side is BC. So tan 30 is 1 by root 3. H we'll have to find out. BC is given as 500 meters. So what do we get? We get H is, we will shift 500 to the other side. So we get 500 by root 3 meters. Now we will have to rationalize the denominator. We cannot have root 3 in the denominator. Whenever we have roots in the denominator, we will have to rationalize. How do we rationalize? We will have to multiply and divide by the denominator. So we have root 3 here. We multiply and divide by root 3. So what do we get? This will become 500 into root 3 by root 3 into root 3 is 3. So this is our final answer. Height of the tower is 500 root 3 by 3. Let's take an example where angle of depression is given. So we have a ship masthead which is 40 meter high and the angle of depression of the boat is observed to be at 45 degree. Find the distance from the ship to the boat. So basically, there is a ship and there is a boat, and there is a ship masthead which is 40-meter high. So this is 40-meter in height, and there is a boat. The angle of depression, that is this one, and this will be the horizontal line from the point of observation. So this is 30 degree. This is the angle of depression. We will have to find the distance of the ship. We'll have to find this distance, say D, and this is H. H is the height. So if you look at this diagram, it looks like this triangle. This is the ship head, ship masthead. This is the boat. This is the foot of the ship. Now we'll have to find this distance. And angle of depression is here. This is angle of depression. It's 45 degrees. And angle of depression is 45 degrees. Height is given as, height of the masthead is given as 40 meters. Now we'll have to use the alternate angle concept. The angle of depression is 45 degree. So this angle and the opposite side of the angle on the same line is same. So this will be 45 degree. Now this is a right angle triangle. We have 45 degree as the angle. We have opposite side given. We'll have to find distance. And what is distance? It is adjacent side. Right? Let's call it as D. And this is height. So again, we will use tan theta formula because we have adjacent side and opposite side. We'll have to find the adjacent side given the opposite side. So tan 45 is opposite side by adjacent side. Opposite side is 40 meters. This one. Let's call this triangle as A, B and C. So opposite side is AB. Adjacent side is BC. What is AB? 40 meters. What is BC? We call it as D, which we have to find out. We'll have to find out this. So tan 45 is 1. 40 by D. So what is D? We'll take it to the other side. We get 40 by 1 or 40 meters. Distance from ship to boat is 40 meters. Let's solve a trigonometry problem related to heights and distances. The problem states that two poles of equal heights are standing opposite to each other on either side of the road, which is 80 meter wide. From a point between them on the road, angles of elevation of the top of the poles are 60 and 30 degree respectively. Find the height of the poles and distance of the point from the poles. So basically, there are two poles on either side of the road. So let's consider this as one pole and this as another pole, and there is a road in between, right? There's a road in between. The road is 80 meter wide. This is the width of the road, and the pole is here. So there is a point on the road from which the angle of elevation is given. That is, from the top of the pole, the angle of elevation is given. The angle of elevation is 60 and 30. So what we have to find is, we have to find the height of the pole. The height, let's say it's H. Height of both the poles is equal. And then we also have to find the distance of this particular point from the pole, that is this distance. Let's call this as A, B, C, D, and this point as E. So let's redraw this. So you have two poles of equal heights. There is a point, angle of elevation is given to this particular point. One is 60 degree and one is 30 degree. This is 80 meter wide. We'll have to find this height. Let's call it H. Let's name the points A, B, C, D, E. We'll also have to find the distance from B to C and C to D. That is from the point of observation to the poles, to the foot of the poles. There are two triangles here, triangle ABC and triangle EDC. Let's take the first triangle, say triangle ABC. Let's use the tan formula because we need to find the height, and we can arrive at the base, the adjacent side length. So we'll use tan 60 because 60 is the angle of elevation here, and the opposite side, tan formula is opposite side by adjacent side. Opposite side is AB by BC. What is AB? We'll call it as H, which we have to find out, and BC we are not aware, so we'll leave it like this. Tan 60 is root 3. So root 3 is H by BC, which means H is equal to root 3 into BC. We have taken BC on the other side and kept H on one side. So let's call this as equation 1. Now let's take triangle EDC, and the angle we have is 30 degree. So we'll take tan 30. Tan 30 is opposite side by adjacent side, which is ED in this case. Opposite to 30 is ED by CD. ED is nothing but H, and CD we are not aware, so we'll keep it like this. Now tan 30 is 1 by root 3, which is equal to H by CD. Now this will be H is equal to, let's take CD on the other side, so it will be CD by root 3. Let's call this as equation 2. From equation 1 and equation 2, height is same, right? Height of both the poles is same. So actually equation 1 and equation 2, LHS is equal. That is, heights are same. So what we will do, since the LHS are equal, the right hand side is also going to be equal, which is nothing but root 3 BC is equal to CD by 3. So we have taken this one and this one. We know that BC and CD together, B to D is 80 meters. So what will be BC? BC will be 80 minus CD. BC would be 80 minus CD because this entire thing is 80, right? So if I minus CD, 80 minus CD will be BC. So let's do that. BC is equal to 80 minus CD. If you substitute this one here, we'll get root 3. BC will let us 80 minus CD is equal to CD by 3. This is nothing but, this is CD by root 3. So we'll take root 3 on the other side. So root 3 into root 3, it will be 3. 3 into 80 minus CD is equal to CD. Now let's simplify this. We'll get 80 into 3 is 240 minus 3 CD is equal to CD, which is nothing but, let's get CD on the other side. So we'll get 240 minus 3 CD minus CD is equal to 0. This is nothing but 240 minus 3 CD and minus CD is going to be minus 4 CD is equal to 0. This is minus 4 CD is equal to, let's take 240 on the other side, it will become minus 240. Nothing but minus and minus will get cancelled. So we'll have 4 CD is equal to 240. Therefore, CD is 240 by 4, which is 60. So CD is 60 meters. So CD is 60 meters. So if CD is 60, then what is BC? The entire length is 80. CD is 60. So BC is going to be 20, right? So this is going to be 20 since this is 60. So BC will be 80 minus CD, which is nothing but 80 minus 60, which is 20 meters. So BC is 20 meters. So we have solved one part of the question, that is to find the distance from the point to the foot of the poles, that is BC and CD. So BC is 20 meters, CD is 60 meters. So what is the height? We need to find the height. Height is, we'll take any one of the equations. Let's take first equation. We'll take root 3 BC. Root 3 into BC is 20 meters. That is 20 root 3 meters is height. Let's solve a trigonometry problem related to heights and distances. The problem states that from the top of 7-meter high building, angle of elevation of top of cable tower is 60 degrees and angle of depression of its foot is 45 degrees. Find the height of the tower. So there are two large objects here. One is the building and the second one is cable tower. So let's first draw the diagram. Let's assume that this is the building and this is the cable tower, right? So what do we have? The angle of elevation from the top of building. From the top of building is nothing but point of observation, right? Because this is from top of high building. So this is our point of observation. So let's draw horizontal line the moment we see, the moment we know the point of observation. Now the angle of elevation, that means the line of sight is above the point of observation. The angle of elevation is given here, which means the object is above the eye level. So that means the tower is actually bigger than the building because the angle of elevation is with top of cable tower and its angle of elevation. So it is at a higher level and the degree given is 60 degrees. The next one is the angle of depression from its foot. That is from the foot of cable tower to the point of observation. This is the point of observation. There is angle of depression. That means it will go below the point of observation, right? This is 45 degree. Let's use alternate angle principle. So the alternate angle on the same side is going to be 45 degrees. This one. Let's name these A, B, C, D, E. Height of the building is given. This is the building for us. This is the building and this is the tower. Height of building is given to be 7 meters. So this is 7 meters. So what we have to find? We have to find height of the tower. That is this one. Let's call it as H. There are two triangles here. Let us shade the triangles. One is this one. BCD. This is one triangle. And the other triangle is ABE. To find the height of the tower, we need to know length of AE and ED. AE will get from triangle ABE using tan formula. And ED is parallel to BC. So ED is same as BC, which is 7 meters. Let's use these two triangles to determine the height. Let's take first triangle, say BCD. I'll take BCD as a first triangle. Angle given is 45 degrees. So tan 45 is opposite by adjacent, which is opposite is BC and adjacent is CD. Opposite to 45 is BC. So BC is 7 by CD is, we don't know, so we leave it like this. Tan 45 is 1, right? So we are going to get 1 is equal to 7 by CD, which means CD is 7 meters. So we got CD. CD is 7 meters. There's one clue here, right? Whenever there is a triangle 45 degree, let's solve that triangle first because tan 45 is 1. So the equation is going to become very simpler. Say in this case, we got directly the length of CD, right? So it's always better to take tan 45 triangle as a first step when we are solving, when we are deciding between which triangle to be taken as the first triangle to solve. Let's take second triangle, which is triangle ABE. And we have 60 degrees. So tan 60 is equal to opposite by adjacent. Opposite of 60 is AE. AE by adjacent is BE. And tan 60 is root 3 is equal to, what is AE? We don't know. So we'll leave it as AE. And what is BE? BE is nothing but the opposite side of this entire rectangle. So we know CD is 7. So B is also going to be 7 because both these sides are equal. So B is going to be same as CD, which is 7. So this will give us AE. AE is 7 root 3. Let's call this as equation 2. This is 1. So we got AE. How do we get ED? ED is nothing but the opposite side of BC, right? It's a rectangle. And these two sides are going to be equal. So this is going to be same as BC, which is 7 meters. So BC is equal to ED is equal to 7 meters. So what is AD? AD is the height. AD is nothing but AE plus ED. And AE we got a 7 root 3 plus ED is 7. So if you simplify this, we'll get 19.12 meters. So this is the height of the tower. So here is an exercise problem where angle of elevation of top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Show that the height of the tower is 6 meters. So basically, there is a tower. There are 2 points at distances of 4 meter and 9 meter from the base of the tower. And both the points are in the same straight line. And the angle of elevation is complementary. So basically, we don't know the angles. The height of the tower is given, which is 6 meters. So we have a tower here. And there are 2 points, A and B, on the ground, both of which are in the same straight line. And they are at a distance of 4 meter and 9 meter. Right? If this is the base of the tower, the first one is at the distance of 4 meter. Second one is at a distance of 9 meter. This is the top of the tower. So the angle of elevation is not given. We don't know the angle of elevation. Height of the tower is given, which is 6 meters. So the height is 6 meters. Let's call this as P and Q. So height has been given, but we'll have to prove that the height is 6 meters. So we'll have to prove this. We cannot use this in the calculations. We'll have to prove that it is 6 meters of height. And one more clue here is both of these angles are complementary to each other. That is, this angle and this angle together are 90 degrees. So if you add this angle and this angle, it's going to be equal to 90 degrees. We have two triangles, triangle PQA and triangle PQB, right? Let's call this as angle A and angle B. When you add both of these angles, it's going to be 90 degree because both are complementary. Now, let's take first triangle, triangle PQA. We'll have to take tan formula because we'll have to prove the height, which is nothing but the opposite side to the angle, and the adjacent side is already given. So let's assume, let's call it as angle A only, right? Let's assume it as A. So this is equal to tan A, we'll call this as angle A and angle B. Tan A is equal to opposite by adjacent. Opposite is, we don't know, it is H. We'll keep it as H because we'll have to prove through calculations that it is going to be 6 meters. Adjacent side is 4 meters. Adjacent is nothing but QA and opposite is PQ. What is tan A? We don't know what tan A is. So we'll leave it like this. So we'll isolate H here. H is equal to tan A into 4. Let's call this as equation 1. Let's take triangle PQB now. We'll call this angle as B. So tan B is equal to opposite by adjacent, which is opposite to tan B is PQ by QB. PQ, we call it as H, and QB is given as 9 meters, right? So we'll isolate H. H will be tan B into 9. So let's call this equation 2. Now what do we do? How do we proceed from here? So one hint or one clue is whenever you have to prove the height of the tower or length we'll have to take these two equations. In any problem, right? We'll have to take these two equations. We'll have to either add them or multiply them. So in this case, we'll multiply them, right? Let's multiply 1 and 2. In some cases, we'll have to add, right? Where you have to find the length of the adjacent side. That case, we'll have to add. But in this case, since we don't know the angles, we will multiply both of this, right? What we will get? We'll get h into h will be h square is equal to 4 tan A into 9 tan B. 4 into 9 is 36 into tan A into tan B. Now, tan A and tan B. Now, angles A and B, if you add together, is going to become 90. So, angle B or B is going to be 90 minus A, right? So, basically, if this is A, this is going to be 90 minus A, right? Because both the angles are stated as complementary. So, what we will do, we'll substitute, we'll keep tan A just like that, and we will write tan B as 90 minus A. So, this will be 36 tan A. Now, tan 90 minus A. What is tan 90 minus A? It is cot A. Similarly, if it was sin 90 minus A, it will be cos A, right? So, this is going to be cot A. Now, what is cot A? Cot A is 1 by tan A. So, let's write that. Is equal to 36 into tan A. Cot A is 1 by tan A. So, this is going to get cancelled and we are going to be left with 36. So, h square is 30. So, h square is 36. So, h square is 36, which means h is square root of 36, which means h is 6. So, we proved that h is 6 meters. So, hence proved. Let's solve a trigonometry problem related to heights and distances. The problem states that a straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with an uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So basically, there is a tower, and from the top of the tower, there's a man watching the car, and the car is approaching at a uniform speed. So basically, there is no change in speed. The speed is uniform, and there is an angle of depression from the point, from the tower till the point of the car. There's an angle of depression of 30 degrees. So we need to find out the time taken for the car to reach the foot of the tower. So let's assume that this is the tower. So the man is standing on the top of the tower. This is the tower. He observes the car at an angle of 30 degree. So there is a depression here because the car that he's looking at is at a lower level. So we need to draw a horizontal line whenever there is angle of depression. So here the angle of depression is 30 degrees. So let's call this as point A, B. Now the car is approaching towards the foot of the tower, right? After 6 seconds, that is after 6 seconds of time, the car will reach one point where the angle of depression changes to 60 degrees. So this angle will be 60 degrees at this point. Let's call it as point C and this as D. The question is, how much time does it take for this car to travel to foot of the tower from this point? So we need to find this time from C to B. So we have time taken by the car to travel from D to C, which is 6 seconds. We'll have to find out this. Let's call this as T1. We'll have to find T1. Now using alternate angle principle, side AD, the alternate angle for side AD is this one. It's 30 degrees. Similarly, there is side AC, which is having an angle of depression, which is 60 degrees. The alternate angle is this one, 60 degrees. It's going to be the same. Alternate angles are going to be same. So we have two triangles here. This is one triangle, triangle ABC. There is another triangle, triangle ABD, the bigger one. So if we have to find time, so we need to know the speed formula. What is speed formula? Speed is equal to distance by time. So we have to find time taken. If we have to find time taken, then we need to know the distance. Speed we don't have to know because speed is going to be constant. So it's going to be the same whether it travels from D to C or C to B. So we have to find the distance. To find the distance, we'll have to use the heights and distances technique. So we'll take first triangle, say triangle ABC. Triangle ABC, we have 60 degree here. So we'll take tan 60. Reason we'll take tan 60 is because we need to find the distance here. If we know the distance BC, right, then we will get the time taken. So we have to find this distance BC. So tan 60 is opposite by adjacent, and that is AB by BC. AB we don't know, and BC also we don't know. So tan 60 is √3. We'll say AB is H. So we'll call this as H by BC. Let's call this as equation 1. Now let's take triangle, the bigger one, ABD. ABD. The angle that we have is 30 degrees over here. So tan 30 is equal to opposite by adjacent. What is the opposite side for this? Opposite to the angle 30 is AB and adjacent is BD. What is AB? AB is H and BD is BC plus CD. BD is BC plus CD and tan 30 is 1 by √3. 1 by √3 is H by BC plus CD. This is nothing but H by BC plus CD is equal to 1 by √3. We'll shift this one to the other side. So we'll get H is equal to, when this goes to the other side, it's going to come in the numerator. So BC plus CD by √3. This is equation 2. Now from 1 and 2, height of the tower is going to be the same. LHS is same in both equation 1 and 2. So if LHS is same, then right hand side also has to be same. So from 1 and 2, LHS are equal. So RHS is equal, which is nothing but √3 BC is equal to BC plus CD by √3. So we'll take √3 here. So it's going to become √3 into √3, which is 3 BC is equal to BC plus CD. If you simplify this, you take BC this side. So it's going to be 3 BC minus BC is equal to CD, which is nothing but 2 BC is CD. Let's call this as equation 3. Now we will have to use the speed distance time formula, and using these expressions and using these values, we'll arrive at the time. Speed taken from D to C. Speed taken by car to move from D to C is distance by time. What is distance here? CD. Time is given as 6 seconds. Similarly, speed taken by car to move from C to B, that is distance is BC. Time we don't know, so it's T1. This is what we have to find out. T1, time taken to travel from C to B, because B is the foot of the tower, and time taken by the car to move from C to foot of the tower is what we need to find out. So let's call this as equation 4 and equation 5. From 4 and 5, speed is same, right? The speed of the car is moving at a uniform speed. The car is moving at a uniform speed from D to B. There is no variation in the speed. So speed from D to C and speed from C to B is equal. So LHS is equal. LHS is equal. So RHS also will be equal. What is RHS for equation 4 and 5? CD by 6 is BC by T1. So both of these are going to be equal. Now CD, from the earlier calculations using tan 30 and tan 60, we got 2 BC is CD. Let's substitute it here, right? So we'll substitute CD as 2 BC. Substitute CD as 2 BC. We get 2 BC by 6 is equal to BC by T1. BC here and BC here will get cancelled. We'll be left with 2 by 6 is equal to 1 by T1. This will get cancelled. So we'll get 1 by T1 is equal to 1 by 3. This is nothing but T1 is equal to 3 seconds. So time taken to travel by the car from C to B is 3 seconds.